Okay, my name is Derek McGallion. I'm going to be attempting a problem for physics dealing with forces. Um, the problem is going to come from this book on page 68, and it's going to be number 72 and 73 as is part of one major problem. This is the problem. A crate of potatoes of mass 18 kilograms is on a ramp with an angle of incline 30 degrees to the horizontal. The coefficient of friction are mu of s 0.75 and mu of k 0.40. I'm going to find the normal force magnitude and frictional force magnitude and direction on the crate. I'm going to attempt number 72 and 73, the crate at rest and the crate sliding down the ramp. So I'm going to try to set this up. Okay, so I'm going to first draw my diagram. And the crate is at a 30 degree, is on a 30-degree angle. The crate weighs 18 kilograms. Okay, so looking back in the book. Right now, what I'm going to do is I'm going to write down all my givens. So they're giving me my mu of s, which is for static, and that equals 0.75. And my mu of k, which equals 0.40. Okay, so what else do I know? Given that this is a crate that's on the surface, I know I'm going to have a normal force. Also, I know what's acting on this crate is gravitational force. And it is said to have frictional force. So, knowing that I know that the crate is 18 kilograms and that gravitation, I'm going to do my mass times gravity. That's for my weight. So knowing that the crate is 18 kilograms and that gravity has a 9.8, I'm going to write that here. Weight equals mass times gravity, which equals 18 kilograms times 9.8. And that equals 176.4. Okay, I'm just gonna write it down here since I ran out of space. 176 All right, now one little rule that one little thing that I learned was that I can tilt it a little bit to kind of better, understand. How can I explain this? I'm just going to tilt it. And this would be my X axis here. It just, I guess it seems better. It looks better. And I'm gonna try that. And this would be my 30 degrees angle. So, since this is my X perpendicular to the X angle, this will be my X right here. And of course, this is my hypotenuse, so this will be my Y. So, given what I know, I can find my X and my Y's angles. So, X hat equals this angle. So, opposite was sine. So, it's opposite over hypotenuse. So, sine 30. And I'm going to set that X over my weight. And that's going to, I'm solving for X, so pretty much it's going to be 176.8 sine 30. And then I can also get my Y. And this is going to be cosine adjacent over hypotenuse. Same over the weight. Solving for Y. Implement 176.4 cosine 30. Okay. Now I can plug both sine and cosines into my calculator. 176.8 sine 30 equals 88.4. And then I'll do my 176.4 cosine 30, and I get 152.8. Okay. So, now that I have that, Well, what else do I know? Well, I know that since my X and my Y is pretty much in this quadrant, I can just pretty much go ahead on and say that my X 0.2 just show that is just show that is in the negative, and my Y I meant put 4. All right. So now that I figured out my X and my Y's, I can also go ahead and attempt to find my friction force. And well, since I'm doing static first, since the crater is not moving, I know my friction force for static mu of S times normal force. So mu of X times normal force would be along my Y, since it's pushing back up. Well, since the mass and the gravity is pushing down, my normal force would be directly proportional. I think that's the word, pushing right back up. So my normal force would be the 152.8. So that would be mu of S, which is up here, mu of S, 7.5. I mean 0.75 times 152.8, which will give me 152.8 times 0.75, and that gives me 114.6. And my friction force will be in the positive direction. Why? Because it's pushing against the weight. The weight is trying to come down, and the frictional force is pushing against it, holding it, keeping it static. So that will make the frictional force positive. Now, in order to find my kinetic, is my kinetic frictional force is mu K times normal force, and the mu of K is 0.40 times the same normal force of 152.8. And that would give me 2.8 times 61.2. I mean 61.12.